Our next lesson is called Arithmetic and Geometric Sequences. So first we're going to look at one more challenging sequence task, and we're going to do one for arithmetic as well as geometric. So we'll start with arithmetic. It says an arithmetic sequence has a third term of 4 and a seventh term of 22. So for the first time, I'm giving you two non-consecutive terms, and neither of them are the first term. Okay, so I'm going to highlight that we have the third term of 4 and a seventh term of 22. Okay, because this is arithmetic, I'm going to up top remind us of what that is on the formula sheet. A sub n equals a sub 1 plus d times n minus 1. That's the formula that we're using for arithmetic. So this is telling me that the third term, a sub 3, is 4, and the seventh term, a sub 7, is 22. So the first thing we want to do is actually create a system of equations, one each using each of these terms. So I'm going to start with the third term, which is 4. That would be equal to a sub 1, which we don't know, plus the common difference, which we also don't know, times n minus 1, but I know n is 3 because 4 was the third term. So 3 minus 1. Then I'm going to create a second equation with the other term they gave us. So the seventh term is 22. So 22 is equal to the first term, which we don't know, plus the common difference, which we don't know. But here, I'm not going to do n minus 1. I'm going to do 7 minus 1 because it was the seventh term. So simplified, we're looking at a system where it's 4 equals a sub 1 plus 2d, and 22 equals a sub 1 plus 6d. So step 1 is going to be creating that system. So use your terms to do that. Now in 2, we are going to solve the system using substitution. Okay, so I'm going to copy these again. 4 equals a sub 1 plus 2d, and 22 equals a sub 1 plus 6d. I'm going to use substitution on the top one, and I can kind of do this just in one step. I want a sub 1 to be alone. So if I look at the equation, I have to subtract 2d to do that. So this other side is turning into 4 minus 2d. Now I can take what a sub 1 is equal to and put it in the other equation in a sub 1's spot. So this is really 22 equals a sub 1 is now 4 minus 2d and then plus 6d. So now I can combine my like terms. 22 equals negative 2d and positive 6d would be 4d plus 4. I can d alone by subtracting 4 from both sides. So that would be 18 equals 4d. And then I would divide both sides by 4 to see that d is equal to 4.5 or 4.5 as a fraction. So now I know the common difference. I'm going to use one of my equations to now find the first term. So I'm going to choose the top one. 4 equals a sub 1 plus 2d. I know the d now. So 4 is equal to a sub 1 plus 2 times 4.5. So that means 4 equals a sub 1. 2 times 4.5 would be plus 9. And I can subtract 9 from both sides to get negative 5 is equal to a sub 1. So now I know a sub 1 and I know the common difference. I have what I need to write the formula. So in step 4, write the formula for the nth term of the sequence. A sub n equals negative 5 plus the common difference, which is 4.5, times n minus 1. That is the formula. Now we can also do the same thing for geometric. So for geometric, they said the fifth term is 14 and the seventh term is 0.56. This is geometric this time, so I'm going to write the generic formula. A sub n equals a sub 1 to the r, or times r to the n minus 1. And that's what we're going to use to help us do this, okay? So the fifth term, that means a sub 5 is 14. And the seventh term, that means a sub 7, is 0.56. So we're going to create a system of equations just like we did before. We'll start with the fifth term, which I know is 14. That's going to be equal to a sub 1, which I don't know, times the ratio, which I don't know. But then instead of writing n minus 1, I'm going to write 5 minus 1 because I know 14 is the fifth term, so n is 5. Then I'll do the same thing for the seventh term. 0.56 equals a sub 1 times the common ratio. We don't know either of those things. But instead of writing n minus 1, I'll write 7 minus 1 because we're using the seventh term. So simplifying that, I would get 14 equals a sub 1 times r to the fourth. And 0.56 equals a sub 1 times r to the sixth. So now what I'm going to do is I'm going to solve this system using substitution. So I'll copy it over. 14 equals a sub 1 times r to the fourth. And 0.56 equals a sub 1 times r to the sixth. And I'm going to use substitution to change this first one. So I want to get a sub 1 by itself. So a sub 1 equals, in order to have done that, I would have had to divide both sides by r to the fourth. So this is 14 over r to the fourth, and I can leave it just like that. So now I can substitute a sub 1 into the other equation in a sub 1 spot. So this becomes 0.56 equals a sub 1, which is 14 over r to the fourth, times the r to the sixth that was already there. So if we multiply across the top, we get 0.56 equals 14 r to the sixth, because this is really over 1, over r to the fourth. We know that we can take r to the sixth and r to the fourth and divide them. So this is really 0.56 equals 14r squared, because r to the sixth over r to the fourth is r squared. So to get r squared by itself, I'd have to divide both sides by 14. When I do that, I end up with r squared equals 0.04. And then to get r alone, I would take the square root. So I find out that r is equal to 0.2, or I could write that as 1/5. So now that I found what r is, I'm going to use one of the equations to find a sub 1. So I'm going to use the first one. 14 equals a sub 1 r to the fourth. However, I now know the ratio is 0.2 or 1/5. So 14 equals a sub 1 times 0.2 to the fourth power. When I find out what 0.2 to the fourth power is, I get 14 equals, my answer would be 0.0016 and then a sub 1, which means I have to divide both sides by the 0.0016 in order to get a sub 1 alone, and a sub 1 ends up being 8,750. So now that I know a sub 1, and I know the common ratio, I have enough to write my formula. So I would get a sub n equals 8,750 is my first term, 0.2 is my ratio, and n minus 1 is my exponent. Or, remember, I can write it with a fraction. A sub n equals 8,750 times 1/5 to the n minus 1. And either one would be okay. And that concludes your lesson on arithmetic and geometric sequences.